Hi and welcome to the second in a short series of videos on how to get up to speed with WebDriver. In the first video we looked at getting your environment up and running, and in this one we're looking at the WebDriver standard template, basically going through its structure and some of the methods it provides for us. I should begin by saying the standard template will change over time, so there's a good chance when you view these, it may not be up to date. Some of the methods may be different, maybe new methods, but this should be enough to give you a basic grounding on what it's supposed to do and how it does it. So first of all, if you've gone through the previous video setting up your environment, you should end up with something roughly similar to this. So here we have our test project over here with our C# file, which contains all of our tests and our references, the WebDriver, WebDriver.support and system.drawing. Now if we look at the standard template itself, you can see that it's a collection of regions. So if I collapse these, you can see that every test file will probably contain these sections. There's configuration, inputs, setup and teardown, tests, obviously, the location methods and some support methods. Now we'll go through each of these in turn. Before we do, you can see here that the main class is tagged as a test class. This just means it's going to contain a series of test methods or tests. It's named and its syntax is exactly the same as any standard class. So if we look at the configuration section, you can see we specify our driver through which we'll interact with the browser. We're saying this is of type iWebDriver. iWebDriver is an interface. We'll look at the ramifications of that later. This second point here is our target, it's our test target. It's used by some of the methods below just to start each of your tests. So if you're working on the building regs or something like that, then that would be a test target. It's basically your landing page, so it's not just the domain. So if you're working on domestic, it may be something along those lines, but for these tests we're just using the mbs.com. Next, we're specifying a standard timeout. I'll come to that in a second. I think that's in the support methods section or something. It's to do with how we deal with page loading times and such. Next is our screenshot path. It's just a constant that we'll use later on to store our screenshots should we create any. Next is the input section, which is empty for this template, and it's there to contain input values. So for example, if you use a login system in your test, you may be storing login details here, email, password. Similarly, you may store invalid emails, invalid passwords, things like that. It's just kind of a scratch pad area for inputs, which you may want to take out later to put in a config file or something, but that's what it's for. Next are our setup and teardown methods. You can see that they have specific tags. Setup method is marked as test initialize, and the teardown is marked as test cleanup. As you can imagine, these basically just mean that this method will run once before every test in your test script. This method will run once after every test in your test script, and they're basically used to maintain state or set up a test state, and also to set up your browser or to configure your browser to whatever configuration you desire for your tests. Now if we look here, it's one example of that. Here we create a Firefox profile object, and on there you can set up your profile in lots of different ways. But here what we do is we just create a new proxy object, set it to auto detect, we plug it into the profile, and here we initialize the Firefox driver, which we kind of saw at the beginning, and we pass in a profile. You don't have to really remember this stuff, but it's just an example of using the setup method to properly configure your browser. In this case, what it's doing is setting up proxy preferences on the Firefox driver to auto detect, which means it should pick up our corporate proxy and use it. If we weren't to do that, the tests wouldn't work, but they do. Next, we have some content outlines. These are worth knowing about. In the previous video we installed Firefox, the latest version, 14.01, which is compatible with WebDriver. However, Firefox has a very busy release schedule, and it's perfectly possible for Firefox to change the browser in such a way that WebDriver can no longer communicate with it. In which case what will happen is, say for example, the browser will update to 15.0. If that isn't compatible with WebDriver, the first you'll probably know about it is when you run your tests, nothing will happen. You'll get a little progress bar in your test window and nothing else. If that does happen, you can uninstall 15 and put 14 back on in its place, but that's not a particularly great solution. What we'd normally recommend would be to install the last compatible version, say 14, to a separate area on your local drive. And if we were to do that, what we would then need to do is this piece of code here. We just need to uncomment this out, correct the path, and then we provide this Firefox binary object to our Firefox driver, and this will basically start us up on the compatible version. Next, we maximize the browser window that the tests will play in. This isn't required for screenshotting. The way we do screenshots in the standard template, it should capture all renderable areas of the page, not the areas that are currently viewed in the browser. So if your web page is 3 page downs long, if you call take screenshot, it will actually capture the entire page, not just what's visible on the monitor. However, we do still maximize the browser here, largely just for debugging, because if something goes wrong in your tests, you want to be able to see it. So that saves a little bit of time. Here we set an implicit timeout. This is probably a good place to talk about this. In Selenium 1, it was pretty common to see a command wait for a page to load, and we'd see this constantly. Almost every time we interacted with a browser, we would then need to tell the tester proxy to wait for the next page to load, and we'd provide a timeout value of 60 seconds or whatever, and we would wait for the page to reload before executing our next test. It's basically just a really ugly and expensive way to handle timeouts. In Selenium WebDriver, we handle it a little differently. So, for example, here is the standard timeout constant we saw earlier, which was set to 1, I think, and we're sending that to a set implicit timeout method. Now, if we go to its definition, you can see here this is just something that we've put in to kind of wrap up a bit of ugly code. You can see it takes the seconds value that we set earlier, and we call driver.manage.time timeouts dot implicitly wait, and then convert the seconds to a time span. And basically what this means is if we set our standard timeout to a second, then we call a method to locate search box. What it will do is it'll poll the DOM, so effectively it'll look for that element immediately. If it's there, it'll return true and you'll carry on. If it's not there, it will wait a short amount of time and then poll the DOM again, and it'll continue doing that until it hits your timeout value. There are two main effects of this. One is the positive effect. It cuts down on fairly useless code. It's easy to read, and it returns you your object in the shortest time possible. However, there's one problem with it. In some of our tests, what we may do is test for the non-existence of an element. So for example, if we have a login test and we go ahead and log in, once we're logged in, we may assert that the login button does not exist, or there's no anchor tags on the page with the text login, which is fairly logical. However, if we set a large implicit timeout of say 10 seconds, as you can imagine, what will happen is it will continue to poll the DOM for that object for the full 10 seconds before returning false, it doesn't exist. It's quite possible, if you have multiple asserts in your test, or certainly multiple negative asserts in your test run, these 10 seconds can actually add up pretty quickly, and they can add a fairly large margin to your test run time, which is something you generally want to avoid. You want to try and keep your tests as fast as possible at all times. So it's just something to keep in mind. In the standard template, it's set to 1 second, which is fine, shouldn't cause any problems. Ordinarily, you probably won't want to keep it much more than say 3 seconds, but it can, I think, depend on your web server. If you're working against a very poor web server, you may need to extend that to a much higher level, but obviously that's going to mean that your tests are going to be very, very slow. But to be fair, if you're going against a very bad web server, your tests are going to be very slow regardless, so it's not the end of the world. So that's the set of test or test initialize method. So we've configured or made any configuration changes we want to our browser, and we've just kind of set our little constants to it so it works the way we want for each test. Moving on to the teardown test, you can see here we don't do a heck of a lot in the standard template at the moment, because the additional things we put in here will tend to be very site specific. So here we just do a driver.quit, which will basically just attempt to close the browser. Pretty basic stuff. What you may want to have at this point is to again manage your state. So for example, if we were testing the mbs.com and our tests, or we know that a fair portion of our tests require a login action to take place, then that means at the end of our tests, a lot of them are going to be left logged in, and that means that the next test that runs, if that attempts to log in, it'll fail, and so we'll basically get kind of like a false negative. To avoid those issues, we need to use the teardown method to try and get us back to that kind of neutral state where every test is going to be as valid regardless of the order in which they're run. So for example, again on the mbs.com, if we know that a lot of our tests are going to log in, what we may do here is have some logic to say something like if logout link exists, click logout. Something like that would probably go some way to achieving a neutral state. Preferably what we could also do here is actually execute a data store rollback for each test, depending on how complicated the data store is. So for example, if there is a license activity table that monitors license activity like session tokenization in the database, then what we could do is in our teardown just execute a rollback of that database, so it kind of forgets that we were logged in at any point. Obviously this requires a bit of communication between the dev teams or BSDS and QA, but if you have the opportunity, try to go down that route because it will be cheaper in the long run. And then we see the set implicit timeout method we saw earlier, so get rid of this one. Next is just our test region. As we saw in this is where we left it off at the end of the last video. This is basically just a test template, so all your other tests would go in here. As you can see, I've tried to comment most of this where I can, so hopefully it makes sense. Best to leave the comments if you can and try to comment your own methods, also your own support methods or your own tests, just to aid reuse. Here we see some of the locator methods. These are basically a nice wrapper around some fairly ugly XPath based location code on the driver. So for example, if you look here, you can see the locate method gets called with an element type, an attribute and a text value, and also has an optional timeout value. So for example, if we wanted to grab hold of the search box on the mbs.com, we would call locate. The element type would be input, the attribute would be ID, and the text value would be search string ID. If we kind of executed that piece of code or that call, it would then return to us the web element representing that search box, at which point we could type in it or take its value or whatever. As you saw there though, we can also specify a timeout value for this individual location alone, so it doesn't change the standard timeout value for the full script. It just specifies how long we are willing to wait for this location. So that could be used, for example, if you know something's going to be very, very slow, or if you don't think something's going to be there, you could modify the timeout appropriately to again keep your tests fast. The code here you can largely ignore because you can see it's kind of obscure really, but effectively what it's doing is, if I scroll across, yeah, okay, you can see what it's doing. I'm grabbing the driver object, so our Firefox driver, I'm calling find element, and I'm locating them by XPath. And what I do here is build up an XPath string referencing the XPath contains function, and as you can imagine, it's just / element type contains attribute text, and then we get back the thing we need. If anything goes wrong, if that element isn't found, so if you typo the XPath, or if the XPath element name changes, or the page doesn't render properly, the following will happen. It'll hit the catch, because it catches kind of the element not found exception, and it'll immediately call assert.fail, and it'll tell you that the timeout expired, locating, etc, etc. And what that means is your test will fail, basically. And you'll see most of the locator methods follow that pattern. Really, we probably want our tests to fail if we can't locate an element for any reason. There's generally not a lot of value in proceeding past the point of an exception. Because of the point the exception has arisen, we're no longer in a predictable state. So something's gone wrong, so if we continue with our test, then the chances are something else is just going to go wrong as well, and we're not going to learn anything from it. And that's the one we tend to use most when we're grabbing elements, just using the locator method. Some of the other ones is slightly different but pretty similar. Here we locate the parent of. So for example, if we have a list of search results, and I can grab the locator of the first search result, but in fact I want its parent, so the container that contains all of the search results. What I can do is call locate parent of. So I'll say locate parent of anchor tag or a tag with class search result or something like that, and it'll return to me the container containing all of the search results, which I can probably then iterate through, etc., etc. Next we have another locate method which works in a very similar fashion to the normal locate method, except we don't specify an attribute. So what we're calling here is something like locate a for anchor tag. Actually no, locate strong. Pardon me. It's a common tag similar to bold. And then we just specify some text that it contains, because what you can often find is you'll have something like an anchor tag, like a link, but where the text should be, and it should just be plain text, you'll often find tagging around that text. So you'll have things like href equals search.aspx, and then where it should just say search, it actually says strong search / strong or whatever. So if we use the any of the automated locators, what will happen is it won't actually pick up on the anchor tag, it'll pick up on the strong tag instead, which isn't a heck of a lot of use. So we have this one, which gives us a little more wiggle room, so we have one more chance before we have to dive into the HTML and create a manual locator. Again, this is pretty similar. This is a really useful method. It's locate all. So again, we could do something like locate all anchor where class equals search result, and return to us a collection of all of the search results. It's really useful. It means we get to avoid a lot of very complicated iteration or looping based on complicated XPaths. It just makes things nice and easy. So what I could do is something like locate all anchor tag class search result, and on the collection that comes back I can then say something like for each search result in search results, and then have some action on those. Next, this is another useful one if the previous methods fail at location. It's locate within. What this means is we again specify our element type, so anchor tag, your attribute, your string value, but you can also specify a parent. So what you'll often find is an element you're interested in just doesn't have any unique locators. The website hasn't been developed in that fashion, and there's a lot of unhelpful naming. So what you may find is there are 3 elements on the page that all share the same locator, but they're in different areas of the page. So what you can actually do is use the locate method that we saw above to grab the parent of the element you want. Then you do another locate for the element you want, and you pass in its parent. So then it's searching not the whole page, but just the actual parent that you've supplied. So again, gives a little more versatility in location. Again, you can kind of tell what this does. It's just as a locate all within. It's the same deal. Lastly, we have an exists. This is kind of a convenience method. Sorry. This is just a convenience method to check, obviously, if an element exists or not. The issue with this is that it's good for readability. However, technically under the hood, it really does almost nothing different when compared to the standard locate method, because the locate method is or has an inherent location or existence assertion. So for example, if you ask the driver to locate a search box and the search box isn't there, it'll return an exception or an assert fail, so you'll know. So you have that inherent assertion of existence. So to an extent, the exists method is a little superfluous. However, it is quite readable, though I suspect we may kind of grow out of it eventually. So that's all the standard location stuff. Lastly, there's just a couple of support methods. As I mentioned earlier, we can take screenshots. And again, you can see this is fairly a convoluted bit of code. So I've just wrapped it up in a take screenshot method just to keep things simple. And again, this is for visual verification of pages, or to take screenshots of errors and things like that. For example, if you try to locate the search box and it fails, we may want to take a screenshot at that point. But obviously it depends on the actual test you're writing. Lastly, we have some window management methods. So for example, if you click on a link and it opens in a new tab, traditionally for Selenium that's a real problem. With WebDriver it's a little easier. So if I was to click a link in my test and it opens a new tab, all I need to do is call switch to new window, and that's what it'll do. It'll move to the new window so we can make some assertions, and then I can use switch to original window to bring it back to end our test. If you find yourself with a lot of windows, you can grab a window via its index, with 0 being your original window. And that's pretty much it. We've wrapped up an open URL link. It's not terribly important. So that's it. That's the WebDriver standard template. As I said earlier, I would not be surprised if this is constantly under revision. For example, as I said, there's probably a better solution out there to that exists method, and also as we kind of optimize timeouts and things like that, I imagine it will change, but this should give you a good idea. So if you have any questions, please get back to me, and if not, then I'll see you in the next video to look at actually writing some tests.